Hey guys, welcome to the next video on Numpy tutorial for beginners. In the last video, I have given you a brief introduction about Numpy, and we have already seen that how we can install Numpy using pip and how to add Numpy library to our PyCharm project. Now to go ahead, I will be using the PyCharm IDE, but you are free to use any other IDE or the editor. So in the PyCharm IDE, what I'm going to do first is I'm going to just open the Python console by clicking on this symbol which says Python console, and I'm going to maximize this console because we will be using this Python console for this lesson. So we have already added the Numpy library to our project, and we can import the Numpy library to the Python console also. So I'm going to just write import numpy as np, and then what we are going to do in this video is we are going to try to compare the Python list to the numpy array, and we will see the similarities or the difference between the numpy array and the Python list. So to start with, I'm going to declare a Python list, and let's assign some values to the list. Let's say 1, 2, 3. And I'm going to declare the numpy array, and I'm going to name it as NA, and we are going to just say np.array, and we will pass the list content to the array function. So we have numpy array and the Python list, and they contain same number of elements. Now what is the basic operation we perform with the list or an array? We iterate over the list and the array. So we are going to iterate over the list first of all. So for I in L, and we are going to print the value of I, and let's see what happens when we iterate over the list. So the result is expected. It's going to print the content of the list, and same we will do with our numpy array, which is to iterate over this array, and the result is same as the list. So we can iterate over the numpy array or the Python list using a for loop. So at this point, these two things look similar. Now let's try to add some elements to the list and the numpy array. So first of all, in order to add something to the list, let's say I'm going to declare the variable L1, and I'm going to add something to the list, and this we can do with the concatenation operator. So let's say we want to add 4 to our list and then transfer the result into L1, and when we see the content of L1, you will be able to see that 4 is added or appended to the list. Now there is one more way in which you can append an element to the list, and that is by using the append function. So let's say I want to append 5 to this list L1. I can do that and see the content of the list. So now our list contains 1, 2, 3, 4, 5. So 5 elements. Let's try to do the same with the numpy array. So I'm going to just use the NA1, and then I'm going to try to concatenate the NA with some elements. So let's try to add 4 to the numpy array, and I'm going to just see the content of NA1, and you can see this is not the expected result. So in case of numpy array, when we use this plus operator, it will do the vector addition. So basically what we are doing is we are adding 4 to each and every element of the array. So as we already know that the content of the numpy array was 1, 2, 3, and when we add 4 to each element, it becomes 5, 6, and 7, and that is the result you are seeing here. So in this way, numpy array and list behave a little bit differently. Now let's try to use the append method on the numpy array. So I'm going to just write na.append, and we will try to append let's say 8 to our list, and then press enter, and it's going to give us error because this append method is not even there inside the numpy array. So at this point, it looks like that lists are winning over the NumPy array. But as soon as we try to do the vector addition or matrix operations, we will see the differences between the NumPy array and the Python list. So as I told you in the last video that generally we use NumPy to do operation on the n-dimensional array. So for example, if you want to do the vector addition of the, let's say, NumPy array to itself, what we can do here is I'm going to declare one more variable na2, and then we can do na plus na, and it's going to give us the vector addition of these two arrays. So I'm going to just see the content of na2, and you can see it has given us the vector addition of na plus na, which is 1 plus 1 is equal to 2, 2 plus 2 is equal to 4, and 3 plus 3 is equal to 6. Now in case of list, as you have already seen, that when we perform the concatenation operator, it's going to just append to itself. So let's try to do that also. So I'm going to declare the L2 variable, and I'm going to just do the concatenation of L plus L, and when we try to see the content of L2, it's just the appending of those two lists, but it's not the vector addition. So if you want to perform the vector addition on the list, what we can do is we can just define L3 variable, and we will assign the empty list here, and then we will iterate over the list using the for loop. So for I in L, and then we are going to just say L3 dot append, and we are going to append I plus I, which is this variable, to the list 3 or L3 variable. And then when we see the content of L3, you will see the expected result, which is 246, which is the vector addition of L plus L. Now let's try to multiply a scalar with the vector. So we have a NumPy array, and I will just multiply it by 2. So I'm going to just write 2 asterisk NA and then press enter, and I can see the error because NA should be in capital. So once again I'm going to just write 2 multiplied by NA and then press enter, and it's going to give us the multiplication of scalar, which is 2, with the vector, which is NumPy array. The similar operation when we perform on the list, let's try to do that. So 2 multiplied by L and then press enter. You can see the result is the repetition of L multiplied by whatever scalar you write here. So L is just repeated 2 times in case of multiplication. So in case you want to do the scalar multiplication with the vector, once again you need to iterate over the list, and you need to multiply each and every element of the list by 2, as we have done with the vector addition. Let's try something else. So let's say we want to find out the power of something. So I'm going to just say NA, and then we already know that when we use double asterisk, it means NA to the power whatever we write here. So NA to the power 2, and what we get here is the squared result of every element. So 1, 4, 9 here. And when we do the same thing with the list, it's going to give us some error. So let's see what error we get, and you can see this operation is not supported. So we cannot perform this kind of power operation on our list. So if you want to perform this power operation on the list, you need to use the for loop once again, and in that way NumPy arrays are a little bit easier to use, and you just need to use the operation whatever you want to perform, and this operation will be performed on each and every element of the list. Now you can imagine if you want to perform the similar operation, vector addition or addition of scalar and the vector, or the power operation to each and every element of matrix, which is a 2-dimensional array, then how difficult it will be to perform on a list, and how easy it is to perform on a NumPy array. So if you want to square each and every element of the list, you can just write for I in L, and then what you can do is you can just square each and every element of the list. So I'm going to just write print here, and then I'm going to just say I multiplied by I, and it's going to give us the square result of each and every element of the list, which is 149. And you can just append this result to a new list, which will give you the similar result as we have seen in the case of numpy array. Now let's say you want to perform the square root on each and every element. You can use sqrt function and then pass your numpy array variable to it, and it's going to give you the square root of each and every element. You can also find out the log of each and every element, so you can just say log and then pass the numpy array here, and you will find out the log of each and every element. You can even find the exponential of each and every element using the exp function and then passing the numpy array to it, and you can see it has given us the exponential of each and every element. So here we have seen some similarities and some differences between the Python lists and numpy arrays, but this doesn't mean that numpy array are better or Python lists are not better. Both have their importance. Sometimes you need Python lists and other times you need numpy arrays. Usually you can treat a Python list as an array, but you can treat numpy array as a vector. That means you can perform the vector operation on the numpy array. And as we have already seen, to do operations on every element of the list, we need to use the for loop, and in case of numpy array, we can do it in much easier way. Loops are slower than numpy array operations. That's why also we use numpy arrays. So at the end, I will just say that if you want to perform these kind of mathematical operations on a list or an array, numpy is not just more efficient, it is more convenient to use because you get a lot of vector and matrix operations for free, which sometimes allows us to avoid unnecessary work which is required in the case of Python lists. So that's it for this video. I will see you in the next video.